Professor Pelton. This is Math202M, Chapter 4, Section 1. This is Part 3 of the basics of probability. So odds is the ratio between the amount staked by the parties to a bet based on the expected probability of either way. Okay, because you can win or lose. So the odds, which are broken into actual odds against or actual odds in favor, which are two flips of a coin, basically. What's my probability of winning or losing? It's two flips of a coin, because one has to do with the other, which is different than the actual payoff odds. Payoff odds are subjective, based on the decision of the proprietor of the game. Okay, so the way I remember it myself is you either win or lose, and you take those two probabilities. If it's against, that probability is the against going on top. If it's in favor, the favor goes on top, and then obviously the vice versa goes on the bottom. Okay, and typically it's written in the colon format for games. The payoff odds will be a little bit different. We'll do those secondly, which is the net profit to the amount bet. Okay, that is typically the ratio that is given. So you have to bet money to get a. So for every dollar bet, this is what you get. That's typically how it's written. Okay. So we take a standard American roulette wheel as an example. Which there are 38 numbers. So what is the probability of getting 13? Well, it doesn't really matter what number you pick. They're all equally likely. It's 1 out of 38 to get 13, which means there's a 37 out of 38 chance you're not going to get 13. So the odds against me are against, or not, over actually being, which is 37 to 1, or 37 colon 1 would be the correct answer. So these don't change for the odds in favor. So if I put the favor on top, that's 1 to 38, or 37 to 38, which is 1 to 37, or 1 colon 37. So basically there's 37 ways to lose, 1 way to win, or 1 way to win, 37 ways to lose, depending on how you want to look at it as my odds against me or odds in favor of me. Okay, so if I do the odds of betting, the payoff odds, that's different than the odds of winning or losing. Okay, so we're betting $5. The game, if you look up above, says that they're paying 35 to 1. Okay, so if I multiply that, that is 175 over 1, which is not what they actually give me. That is the profit. If I add in the original $5 bet, because you have to give $5 onto the board, but they give you that $5. They don't keep your bet. So it gives you a total of $180, which is what they return to you. Okay? So, what do you win? You win $180, but it's not all profit. Okay, only $175 is a profit. Okay? So, the odds of the game are not the same as the odds of what they pay. So why is that? Well, let's break it down into 3 different categories. So we found that it's 37 to 1. Okay, so they're going to, if they paid 37 to 1, so add exactly 37 to 1, what would happen? So if I go less than that, so that'd be $36.99 to 1. Okay. And vice versa, $37.01 to 1. Okay. So what this is saying is they're paying $37.01 for every dollar you bet, or they're paying $37 for every dollar you bet, or $36.99 for every dollar that you bet. So in the first case, in the middle one, the casino breaks even, assuming there's no overhead, which of course there is. So they would break even, because if you sat there over a period of time and played 38 rounds, you would win once and lose 37 times, and basically you'd win enough on that once to break even with the 37 times you lose. So nobody's making any money, neither you nor the casino. And the $36.99 to 1, the casino makes a profit because they're paying you less than the expected outcome. Therefore, that one time that you win is not going to make up for what you lost. Versus $37.01, the casino will lose money, meaning they're paying too much. With every time you win, you're winning more than what you would have lost in the other rounds, so you're getting paid too much. Okay? Oh, so that's or more. I'm sorry, that's or more or less, right? Because you want to pay, because you can pay $36.98 or 97 cents, so on and so forth. Typically, they don't pay pennies in a casino. It's usually whole dollar amounts, typically in iterations of 5 or 10. But for the math's sake, we'll round to a penny, since that's our numeric dollar system here. All right, pause the video. Try the next page. Alright, Sic Bo is a very popular 3-dice game. You roll 3 dice, and you get many, many different combinations, and the board down below dictates the many different types of possibilities of what you could bet on. One of them that's very popular is called trips, which is when you bet on all 3 dice being the same, and there are, of course, 6 combinations, so there are only 6 ways to get that, and if you want to know how many total combinations there are, 6 times 6 times 6 is 216. So there are 216 possible different outcomes. Only 6 of them are trips. Okay? Okay. And if you win here, 30 to 1, or 1 pays 30, is what this board pays for payoff odds. Okay, so let's go down and do the math here. So they get the probability of winning and the probability of not winning. Well, there are 6 ways to get the trips, so it's 6 out of 216, which means there's 210 ways to lose. So we have the actual odds against, and this one's asking for the actual odds in favor, which are 2 flips of a coin depending on how you're asking the question. So in this case, we get against, which is 210 over 216 over 6 over 216. Vice versa, in favor is 6 to 216 over 210 to 216, which is 210 over 6 or 6 over 210, which if you simplify the fraction is 35 to 1 or 1 to 35, which is written 35 colon 1 or 1 to 35. So there are 35 ways to lose, 1 way to win when it's simplified. Okay. So if they pay if you bet $25, I'm sorry, you bet $25. So it's not 35 to 1 in the payoff odds. If you read above, they said the payoff odds are 30 to 1. Well, 25 times 30 is 750 to 1, which is not what they're giving you. They're giving you $775 if you actually bet on and win. Okay, so there's another $25 that comes in because this is your profit. But you get the original bet back, which makes your total return of $775. So, as a casino operator, what are the odds up and down for winning and losing? Okay, well, we figured out that 35 to 1 was the break point. So you're either at 35 to 1, you're or below. Actually, we should reword that actually, because we could get 34.99 to 1 or less. Alright, obviously they're not paying pennies, but and then 35.01 to 1 or more. So the middle one would be if you bet $1 for you get paid 35. Okay? So in this case, in the middle, the casino breaks even, right? So you win once, you lose 35 times, but you're not going to make any money or lose any money because it equates to each other. In the case below, the casino makes a profit because they're paying less than the odds. You're not going to get paid enough on the win to circumvent the losses, assuming the probability plays out. In the top case, the casino is paying too much. The casino loses money because they're paying too much on the win, and the losses don't equate for that. Okay, that is the end of part 3.